Yes, folks, we are quickly back with even the next video of that same identical problems that we were doing. Now we are into the problem number 16, and problem number 16 says that find the sum of two positive numbers whose sum is 16 and sum of the cubes is, you look at this, sum of the cubes is minimum. Little change in the kind of question that's being put. Earlier they used to put product, some different kinds of products, but here they are saying now the sum of cubes. It's being written on the board. Let's continue right away. They've told you that the sum is 16, but here they don't give you x and y. The past 2-3 problems they were giving x and y, so we just had to do the problem. Since here the things are not given, we have to make assumptions. So let's make the assumption. So we'll say that let x comma y be the numbers. Yeah. So given that, they give us that x plus y is 16 and the sum of cubes, or you could call it as S or P or whatever. So for our convenience, let's see, we'll require this substitution and leave some place and see what should be a good substitution. Also, they give us that sum of cubes, which I prefer to call S, is x cube plus y cube. This is what we have to differentiate, but then two variables. So equivalent, both ways, whatever you want to substitute. Suppose you substitute y as 16 minus x, then your S becomes x cube plus 16 minus x the whole cube. So let's work on this. Yeah, we have to work on it. We are with one variable now. So our first thing is to get the first derivative. That is going to be 3x squared. And the derivative of this term, it's going to be 3 times 16 minus x the whole squared. And we have to account for the minus x over there. So this is going to be our first derivative. Let's also go for the second derivative. Our second derivative is going to be 6x. There is a minus 3. All right, let's consider this is minus 3 and times 2, 16 minus x, and the minus again has to be accounted for. So that's our first derivative and second derivative. We'll quickly go, because we know we have to get the critical point. So let's quickly go and find out the critical point. Let ds over dx be equal to 0. So that will give us 3x squared minus 3 times 16 minus x the whole squared equal to 0. So that way we'll get 3x squared equal to 3 times 16 minus x the whole squared. We can comfortably cut the x and let's expand. We have cut the 3. Now let's expand this. It is 256 minus 32x plus x squared. So the x squared gets cancelled. We get 32x becoming 256, which is 256 over 32. I don't know, I can get it like this, 16 2 times and 16 16 times. So 8 times. It's 8 times. So x is 8. So getting x as 8 automatically from this equation, it's clear that y is also 8. So no two values. Otherwise, generally we have the two values and then we have to eliminate one value by giving a valid reason and all that. So now here x is 8 and y is 8. We should quickly determine whether it is, you do get a hint from the question, but then let's also check whose cubes are minimum. They have said that it's a minimum. So let's confirm that it's minimum. So for that, therefore, d squared s over dx squared at x equal to 8. Let's see what happens. It is 6x, so it is 6 times 8 plus this minus and this minus will become plus. So it is plus 6 times 16 minus 8. So that's going to be 6 times 8, 48 plus 48, to 48, it's 96, which is positive. So therefore, minima occurs. That's it. So they have said that there should be a minimum. And let's see what they ask us in particular. Find the two positive numbers whose sum is this and cube is minimum. Yeah. So the positive numbers, the required numbers are 8 and 8. So that's about it. That gives us some scope to take the 17th problem also. Let's check the 17th. Oh, yeah. 17th problem. We need to be having a bit of paper cutting. So we'll not take it from this, we'll take it in another video where we'll have a paper cutting and get an idea of it and then go about doing this problem. That's all for this video. For this small little problem, which is very easy and we got it really easily, that's about it. We can, with the next problem, we can come in the next video. Thank you.